disguised weather balloon. An Air Force spokesman confirms tonight that this was no flying saucer.
We have a request for communication.
The one that I have on the rotor, I exchange it with the one that is wounded with 60 turns each coil of 33 gauge, and that's a very fine wire. This is 30, and I was able to turn 60 per coil. That'll be 120, and that renders a resistance around 4.3 ohms. And I had to do this test so you guys see that it's the amp draw is all related to the resistance that we got on our coils. However, this is important. If we have a too high resistance, the RPMs will not get higher. The magnetic field will not be strong enough. And that's the reason why I insist on anywhere in between 1.3 to 2.0, 2 point something ohms per group or per pairs. Now, this motor here, it will not start at the other one with lower resistance. This one will go pretty smooth, you can see, and it's consuming 29 milliamps, and it's producing, the meter, it's out there, 1.4 volts, which is attached to the, remember this is diagonal here, it works in diagonal, input, output. So wanna get the camera out a little bit so we can see. Then I'm gonna hire. I went over to 3.8 and this 6,000, got a hard time having this 6,500. So anyways, I'm gonna go higher. Still at half an amp, and we're 22.8 here, 22.9, 23,000, and we are at 0.47, and we can see how the output jumps, because this is recycling the power out. So sometimes we got more, and also the power source resets. So anyway, this motor, I had a little trouble with one of the coils, 22.9. And we're gonna turn it off. Now I want to do the other test, which is the one that we apply on the first motor, doing the torque. Not the torque. I'm sorry. It was coming loose already, so I should have put a whole wrap around, but I wanted to check this. Now, this video I'm not gonna edit it or anything, it's just gonna go like this, and just want you guys to see. Now, I'm not gonna read power out, I'm just gonna read what it can do. Now it's much smoother running it this way, and can go low to even 2.6. and 0.13 amps. Oh, this is cute. And I'm gonna take it to the max right there, and it's 0.17. And it's doing 13,000. 13,000. And it's at 0.50, 0.17. So what I want to do now is to get this hooked in there. Set these for, and I'm gonna get this. I'm gonna have to unhook the power. Put it right here. And what I'm doing here is I'm hooking the bulb, and I'm hooking also the amp meter. And I have this cable right here that I soldered it's now on direct DC. I pushed the button by mistake. So anyways, I want to see this because I want you to see the acceleration. The power source is at max output, completely max. So whatever RPMs is rendering here, this is it. There's nowhere to go to get more RPMs. No more juices here. So we got 13.3, and the power source is set. Now watch this, because now we get 14,500, and the power source increased only by a few milliamps, and we're showing here 1.3 amps, 1.03, and I believe we have a fully lit bulb. I believe this is pretty interesting. I would say so, because we actually are getting more amperage in the output through the bulb than what the power source is rendering. Plus, we're getting a higher RPM that the power source is not capable of doing. If you look at the two buttons on the power source, it is a max. There's no more on it. And that power source is regulated only, max is 3 amps and 19 volts. So, but still, where is that power coming on that is letting me? Right now it's running on without the bulb, and it's going back to 13,258, 300 RPMs. And again, the power source is at max right there. Okay, there's 0.28. Now the circuit is open on the bulb, and I would like you guys to see this, because this is what I would like to go over in the forum in detail here. Because I mean, we need to dissect this motor and see where is it pulling this. See, watch this. I mean, you seeing that the RPM automatically went up to 14.4. That's 1,000 RPMs more. We got a bulb bleed and 0.96 versus 0.84, 85 at the power source amps. All right, thank you. Disconnect the bulb. We got 13.4. And we got 0.29 amps here. I mean, it's open. We are 14.4 again. I mean, it's right there. I mean, whatever power is coming from somewhere, it's steadily out there, making the motor go faster, turning on the bulb, and the power source it's a max. Now it went back to 13.3. Thanks, guys. All right, guys. This is a very simple test that I'm running. The meter is connected to continuity, and it'll beep when I touch it, meaning circuit is closed. So I want to make a reading of the casing and the shaft. So you see, guys, that it's now continuity there. There's no connection. Okay, so I touch it here. Of course, I'm touching the contacts. Right here, casing and shaft, there's zero. They're open. Now, casing and any windings, any of the points of the coils is completely also open. Now, from the shaft to the coils, it is also open. Means it's no continuity. Now, if we measure from here to here, it'll give me reading because it's between the two coils and this one too. Now what I'm gonna do is it's a little bit, I consider, pretty interesting test here, and this is the same high resistance for 4.3 per all north running here. And what I'm doing is I'm going to be doing is and this is very interesting here, because you got to realize that this casing here is completely isolated from any wiring, from anything. It's just attached to the magnetic field, to the stators, and so is the shaft right here. The shaft, it runs through the core, but the core has got epoxy, so it's isolated from the wiring. So there shouldn't be any electricity there, any at all. And I have set the meter at 2 volts, which is going to be reading millivolts, basically. And I'm going to start the motor, and I'm going to take a reading on the casing with the negative on the casing, and another one in the shaft, at the center of the shaft, where this attachment, which is metallic, it's attached here. We're not going to measure RPM, so I can even take this little. So you guys see that I'm going right on the center of the shaft, and I want you to remember the end machines and Faraday testing with the magnetic fields. I'm gonna have a reading. It's at 3.9 volts and 13 millivolts. And see, the needle went to 0.50 millivolts, 0.050, but it will go higher as I increase this. It's at 10 volts and I got 117 millivolts there in the casing. But what is interesting is that if I go into the house, the center shaft, I get 380 millivolts. That's energy right there, guys, that it's directly derived from the magnetic fields. Has nothing to do with the output from the motor, which is gonna blow it because I'm on. So I go higher. I don't want to make too much noise. So this right here, I'm reading 175 millivolts, and at the shaft, I'm reading 570 millivolts. It's more than half a volt here. And this is interesting. I believe so, because there shouldn't be any, and I can go higher and measure here. I get 200 millivolts. So these fluctuate with the speed of the motor. And right here we're getting 600, 700. I'm gonna try to 800, almost 1 volt, right at the shaft of this little motor. We're getting 200 millivolts at the casing, which is, again, remember these caps are plastic, so the shaft, there's no connection mechanically or conductive between the shaft and the casing at all. So, but this goes off as I turn off the power, the speed. Start decreasing there, and keeps going down. So it's directly related to the rotation of the magnetic fields in there. Now the higher, of course, I go, I'm almost getting 1 volt there. And 200 millivolts here on the casing. So it's quite something to think about. Interesting, isn't it? Thank you.
A Rick's Progress Story. Rake's progress story.